Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 9th Science chapter 11 Work and Energy notes, that is question answer. And here is our welcome message. Before we begin, we request you to subscribe, like and share our channel with your friends and among your relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded. Now let us begin the lesson. First question is, a force of 7 Newton acts on an object. The displacement is say 8 meter in the direction of the force. Let us take it that force acts on the object through the displacement. What is the work done in this case? So solution is, when the force F acts on an object to displace it through a distance s in its direction, then work done W is on the object by the force is given by work done is equal to force into displacement. W is equal to F into S, where F is equal to 7 Newton, S is equal to 8 meter. Therefore, work done W is equal to 7 into 8, which is 56 Newton meter, or we can write it as a joule. W is equal to 56 joule. Now the next question. What do we say that when do we say that work is done? Answer: work is done whenever the given conditions are satisfied. First, the force acts on the body. Second, there is a displacement of the body caused by the applied force along the direction of the applied force. Next question, write an expression for work done when a force is acting on an object in the direction of its displacement. Answer: when a force F displaces a body through a distance s in the direction of the applied force, then work done W on the body is given by the expression work done is equal to force into displacement, that is work done W is equal to F into S. Next question, define 1 joule of work. Answer: 1 joule of work is the amount of work by a force of 1 Newton on an object that displaces it through a distance of 1 meter in the direction of the applied force. Next question, a pair of bullock exerts a force of 140 Newton on a plow. The field being plowed in 15 meter long is 15 meter long. How much work is done in plowing the length of the field? Answer: work done by the bullocks is given by the expression work done is equal to force into displacement, work W is equal to F into D, where applied force F is equal to 140 Newton, displacement D is equal to 15 Newton, 15 meter, W is equal to 140 into 15, that is 2100 joule. Hence 2100 joule is the work done in plowing the length of the field. Next question, what is the kinetic energy of an object? So kinetic energy is the energy possessed by a body by the virtue of its motion. Every moving object possesses kinetic energy. A body uses kinetic energy to do work. Kinetic energy of hammer is used in driving a nail into a log of wood. Kinetic energy of air is used to run windmill, etc. are the examples. Next question. Write an expression for kinetic energy of an object. Answer. If a body of mass m is moving with a velocity v, then its kinetic energy Ek is given by the expression Ek is equal to half mv square. Its SI unit is joule. J. Question. The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. What is the kinetic energy when its velocity is doubled? What is the kinetic energy when the velocity is increased by 3 times? Okay. Answer is the expression of kinetic energy Ek is equal to half mv square. M is equal to mass of the object, v is equal to velocity of the object, and its unit is meter per second. Ek is equal to 25 joule. First part of the question is if the velocity of the object is doubled, that means v is equal to 5 into 2, that is 10 meter per second. Therefore, the kinetic energy will become 4 times its original value because it is proportional to the square of the velocity. Hence, kinetic energy will be 25 into 4, that is 100 joule. If the velocity is increased 3 times, the kinetic energy will become 9 times than that of original value because it is proportional to the square of the velocity. Hence, the kinetic energy will be 25 into 9, that is 225 joule. Next question. What is power? Answer. Power is the rate of doing work or rate of transfer of energy. If W is the amount of work done in time t, then the power is given by the expression power is equal to work upon time, that is equal to energy upon time, that is P is equal to W by T. It is expressed in watt. Its unit is watt. Define 1 watt of power. Answer. A body is said to have power of 1 watt if it does work at the rate of 1 joule in 1 second. That is 1 watt 1 W is equal to 1 J upon 1 S. Next question. A lamp consumes 1000 joule of electric energy in 10 seconds. What is its power? Power is given by the expression power is equal to work done upon time. Work done is equal to energy consumed by the lamp is equal to 1000 joule. Therefore, power is equal to 1000 upon 10, that is 100 joule per second, that is 100 watt. Define average power. A body can be different amount, can do different amount of work in different amount of time interval. Hence, it is better to find average power. Average power is obtained by dividing the total amount of work done in a total time taken to do this work. Average power is equal to total work done upon total time taken. Next question. Look at the activities listed below. Reason out whether or not work is done in the light of your understanding of the term work. Suma is swimming in a pond. Suma is so answer to do this is Suma is swimming in a pond. Suma is doing work as she is able to move herself, applying force with the movement of her arm and legs in the water. Therefore, work is done. A donkey is carrying a load on its back. A donkey is carrying a load on its back. Donkey is not doing any work in the sense of physics, as the weight he is carrying, the direction of the force and displacement are perpendicular to each other. A windmill is lifting water from a well. A windmill is lifting water from a well. Windmill is lifting water from a well and doing work against the gravity. A green plant is carrying out photosynthesis. A green plant is carrying out photosynthesis. No force and displacement are present here, so no work is done, or work done is zero. An engine is pulling a train. An engine is pulling a train. During the pulling of train, engine does work against friction present between the railway track and wheels. Food grains are getting dried in the sun. Food grains are getting dried in the sun. During the drying of the grain, there is no force as well as displacement is present. Therefore, no work is done. A sailboat is moving due to the wind energy. A sailboat is moving due to the wind energy. Work is done by the wind as it moves the sailboat towards the direction of the for force of blowing air. So this question is finished. Now, next question. An object thrown at a certain angle to the ground moves in a curved path and falls back to the ground. The initial and final point of the path of the object lie on the same horizontal line. What is the work done by the force of gravity on the object? Answer. When the object moves upward, the work done by the gravity is negative, as the direction of gravitational force is towards the Earth's center. And when the uh, object comes downwards, then the positive work is done. So the total work done is zero throughout the motion. Question. A battery lights a bulb. Describe the energy changes or involved in the process. Battery converts chemical energy into electrical energy. This electrical energy is okay. Battery converts chemical energy to electrical energy. This electrical energy is further converted into light energy and heat energy. Next question. Certain force acts on a 20 kg mass. Its velocity from 5 meter per second to 2 meter per second. Calculate changes from its mass changes its velocity from 5 meter per second to 2 meter per second. Calculate the work done by the force. Mass of the body 20 kg. Initial velocity 5 meter per second. Final velocity 2 meter per second. We know that work done is equal to change in kinetic energy, that is half mu square minus half mv square, half m common u square minus v square, half uh, put the value of m, that is 20, put the value of u, that is 5, and put the value of 2 v, that is 2, and then half 20 5 square minus 2 square. On solving we get 210 joule. Next question. A mass of 10 kg is at the point A on a table. It moves to point B If the line joining A and B is horizontal, what is the work done on the object by gravitational force? Explain your answer. The work done by gravitational force acting on the body is zero because the direction of the force is vertically downward and the displacement is horizontal. That is, force and displacement are perpendicular to each other. Next, the potential energy is of a falling object decreases progressively. Does this violate the law of conservation of energy? Why? The potential energy of freely falling object decrease its kinetic energy, increase as its velocity increases progressively. So, in this way, the total mechanical energy, the law of conservation of energy is not violated. Total kinetic energy, that is, so in this way, total mechanical energy, kinetic energy plus potential energy remains constant. Thus, the law of conservation of energy does not violated. Next question: what are the various energy transformation that occurs when you are riding a bicycle? Answer: the muscular energy of the cyclist is converted into kinetic energy or of the will of the cycle, which is converted into kinetic energy to run the bicycle. Question: what does the transfer of energy takes place when you push a huge rock with your mighty uh, all your might and fail it to move? Where is the energy you spend doing? When we push a rock and fail it to move, some of our energy absorbed by the rock in the form of potential energy, and rest of the energy is mm, so some of the energy is absorbed by the rock in the form of potential energy, and rest of the energy uh, goes to the environment through your muscles and the surface between the rock and your hand. Next question: a certain household has consumed 250 units of electric energy during a month. What How much energy is this in joule? We know that 1 joule is equal to 3,600,000 joule. So 250 unit is equal to 250 into 3600,000,000 J, that is 9 to the power 10 to the power 9 into 10 to the power 8 joule. Hence, energy consumed is equal to 9 into 8 10 to the power 8 joule. Next question: an object of mass 40 kg is raised to a height of 5 meter above the ground. What is the potential energy? If the object is allowed to fall, find its kinetic energy when it is halfway down. We know that potential energy is equal to mgh, where m is equal to 40 kg, g is equal to 9.8 meter per second square, and height is uh, 5 meter. So the potential energy, 40 into 9.8 into 5 joule, that is 1960 joule. According to the law of conservation of energy, the total energy, mechanical energy, kinetic plus potential of of an object remains constant. Therefore, when the object is halfway down, its potential energy becomes half of the original state, and remaining half converts into kinetic energy. Hence, the kinetic energy half 1960, that is 980 joule. What is the work done by the force of gravity on a satellite moving around the Earth? Justify your answer. When a satellite moves around the Earth, the displacement short interval is along the tangential direction, and the force, that is gravitational force, is toward the center of the Earth. Since the force and displacement are perpendicular to each other, therefore, so what is the, let us see this question again. What is the work done by the force of gravity on a satellite moving around the Earth? Answer. When the satellite moves around the Earth, the displacement is short interval is along the tangential direction of the gravitational force, is towards the center of the Earth. Since that is force and displacement is perpendicular to each other, the work done by gravitational force is zero. Next question, can there be a displacement of an object in absence of force acting on it? Think, discuss this question with your friends and teacher. Yes, it is true. There may be a displacement in absence of force. We know that F is equal to ma. In absence of force, F is equal to 0, and then ma is equal to 0. A is equal to 0 as m is not equal to 0. If A is equal to 0, the object is either rest or in it in a state of uniform motion in a straight line. In case object is moving in a straight line, there must be a displacement. So in the absence of force, there may be displacement in the object. Next question. A person holds a bundle of hay over his head for 30 minutes and get tired. Has he done some work or not? Justify your answer. The person holding a bundle of hay get tired because his muscular energy is converted into thermal energy. There is no displacement. There is no displacement at all. So he had done no work, as work done is equal to force into displacement. Next question. The electric heater is rated 1500 watt. How much energy does it use in 10 hours? Answer. We know that energy is equal to power into time. Hence, power is equal to 1500 watt. Time is equal to 10 hours. That means 10 into 60 into 60 seconds. That is 36000 seconds. Therefore, energy used by heater is equal to power into time. That is 1500 into 36000 joule. That is 54,000,000 joule into 54 into 107 joule. 5.4 into 107 joule. Next question, illustrate the law of conservation of energy by discussing the energy changes and which which occurs when we draw a pendulum bob in one side and allow it to oscillate. Why does the bob eventually come to rest? What happened to its energy eventually? Is it a violation of law of conservation of energy? In the diagram, we can see that a pendulum is moving. There are three cases of uh, points to be discussed. At so at the point B and C, the pendulum bob is at its maximum height. So the potential energy is maximum and kinetic energy is 0. In this way, the total mechanical energy remains constant. At point A, pendulum bob is at its lowest point, that is total potential energy is converted to kinetic energy. Uh, now the baking now the kinetic energy is maximum and the potential energy is 0. Once again, the total mechanical energy remains constant. Next question, an object of mass m is moving with a constant velocity v. How much work is done on the object in order to bring the object at rest? The object is in motion, so energy is equal to kinetic energy is equal to half mv square. The kinetic energy of the object when it comes to rest is equal to 0. Work done on the object is equal to change in kinetic energy, that is half mv square minus 0, that is half mv square. Next question, question calculate the work done to be stop calculate the work required to be done to stop a car 1500 kg moving at a velocity of 60 km per hour. Answer, mass of the car 1500 kg, velocity of the car uh, currently 60 km per hour, which is equal to 60 into 1000 upon 60 upon 60. On solving, we can get mm, 50 upon 3 meter per second. The car is in motion, so its energy, kinetic energy is equal to half mv square, half 1500, 5 upon 3 whole square, and ultimate result is 208,333.3. The kinetic energy of the car, so kinetic energy is equal to half mv square, that is half 1500, 50 upon 3 whole square joule, half 1500, 50 upon 3 will be can be resolved as 2500 upon 9. The answer is 208,333.3 joule. The kinetic energy of the car when it comes to rest, that is 0 joule. Work done on the object is changed in kinetic energy, that is 208.333.3 minus 0 joule, that is 208,333.3 joule. So the next question is, in each of the following, a force F is acting on an object of mass m. The direction of displacement is from west to east, shown in the figure by arrow. Observe the diagram carefully and state whether the done be work done by the force is negative. Answer, in the first case the force and displacement are perpendicular to each other, so work done is 0. In second case the force and displacement are in the same direction, so work done is positive. In third case, force and acceleration are this force and displacement is opposite is in opposite direction, so the work done is negative. Next question. Sony says that the exertion in an object could be zero even when several forces are acting on it. Do you agree with her? Why? Answer. If the resultant force acting on a body is different in different direction is zero, then the acceleration will be zero. We know that F is equal to ma if in the rest force of 0. F is equal to 0, then ma is equal to 0 and a is equal to, yeah, and a is equal to, F is equal to 0, then ma is equal to 0, therefore a is equal to 0, where m is not equal to 0. Next question. Find the energy in kilowatt hour consumed in 10 hours of 4 devices of power 500 watt each. Answer. The power of 4 devices 4 into 500 watt, that is 2000 watt. Time is equal to 10 hour. Therefore, the energy consumed is equal to power into time, that is 2000 into 10 watt hour, that is 20,000 watt hour, that is 20 kilowatt hour, which is 10 unit, because 1 unit is equal to 1 kilowatt hour. Next question. A freely falling object eventually stopped on reaching the ground. What happened its kinetic energy? Answer. When a freely falling body eventually stops on reaching the ground, its kinetic energy gets converted into heat energy as the body and the ground becomes warm due to the collision. The sound energy and the The freely falling body eventually stops on reaching the ground. Its kinetic energy gets converted to heat energy as the body and the ground becomes warm due to the collision. Sound energy and its kinetic energy gets converted into heat energy and sound energy into the potential and into potential energy due to this change of the shape or deformation. And this is the end of the question answer from chapter 11 ncert, work and energy. Please subscribe, like and share this channel. Please check Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded. Thank you for watching. Keep supporting. Thank you very much.